at an example on simple calculations involving Faraday's laws of electrolysis, okay? So an example on the board is a current of 2 amperes, okay? The current was 2 amperes. It's passed through a copper sulfate solution. So the compound is copper sulfate, okay? For 30 minutes, the time is 30 minutes, okay? Which are going to convert to what? To seconds immediately, okay? Converting into seconds, you simply multiply by what? By 60, okay? So, but we'll do that later. So as we proceed, then they give us the atomic mass of copper and the rest of them, and the valency of copper. So when this copper sulfate goes into solution, it liberates copper 2 ion, okay? Copper 2 ion. The valency of copper is 2. And this copper, when being electrolyzed, will accept 2 electrons to become copper. Right? This is making sense now. So the first step to this question is for us to calculate the quantity of current that will be needed for this electrolysis. The quantity of current is equal to IT. Is that also? So which will be equal to current, which is 2 amperes times 30 minutes. Converting it to seconds, multiply by 60, okay? So when you do this multiplication, you will have 3,600 coulombs. This is the quantity of current that needed to liberate the given mass of copper we are looking for. So, but from Faraday's first and second law of electrolysis, we know that 1 mole of electron is equal to 96,500 coulombs. So, from this equation here, we know that 2 moles, 2 times 96,500 coulombs of electricity will deposit this atomic mass, this mass, based on Faraday's second law, will deposit 63.5. If this quantity of current can deposit this, then 3,600 coulombs will deposit X. And of course, this X will be our answer. So to get this X becomes cross multiply. We have 3,600 times 63.5 all over 2 times 96,500. So X will be equal to the mass of copper, which is equal to 1.18 gram. So it means that this quantity of current will liberate 1.1 gram of copper. So another example on Faraday's first law, Faraday's laws of electrolysis, is on the board here. They said the same current is passed through a solution of a silver nitrate and copper sulfate. So silver nitrate and copper sulfate, okay, for the same time. So meaning that both of them have the same quantity of current passing through them, okay? So if 1.08 gram of silver is deposited, find the mass of copper deposited. So we are going to find the quantity of current that deposited this mass of silver, because this same quantity of current will deposit the same mass when it comes to copper sulfate, since they have the same current at the same time. So how do we get it? It's very simple. Remember that when silver nitrate dissociates in water, you have silver ion, which will accept 1 electron to become ordinary what? Silver atom, which will be deposited at the cathode, okay? So in this reaction now, you will see that 1 mole of electron will deposit this. So if 1 mole of electron deposits this, we know that 1 electron represents 96,500 coulombs, which is the Faraday's constant, okay? So we can say that 96,500 coulombs will deposit the mass, which is the atomic weight or the chemical weight equivalent, which is what? 108 grams. If this quantity of current will deposit this, then X, we don't know this, which is the quantity of current, we will deposit this mass of silver, which is 1.08 gram. So how do we get this X now? Simple. X becomes 96,500 times 1.08 all over 108. So quickly do the division. 96,500 times 1.08 divided by 108. So we're going to have the the quantity of current will become 965 coulombs. Now, this is not the answer. This is the quantity of current that deposited this mass, and it will still be the quantity of current that will deposit any mass that will be in copper sulfate. So now quickly, let's now get what the mass of this copper sulfate that is deposited, which is what we are looking for. So how do we get it? We come back to copper. Remember again that when copper goes into solution in this compound, it forms this ion, copper 2 ion, which will definitely accept 2 electrons when it is being electrolyzed in the solution to deposit copper atom at the cathode. Okay, so we have this equation. So what this means is that 2 times 96,500 coulombs will deposit this mass, this chemical equivalent, or the molecular weight of this guy, which is 63.5 grams. So if this can deposit this, then this same quantity of current that is passed through these 2 solutions will deposit a given mass in this guy, which is 965 coulombs. We deposit X, an unknown. So to get this unknown, X will be equal to 965 times 63.5 all over 2 times 96,500. So let's quickly punch this in calculator. So we're going to have 965 times 63.5 equal to, divided by 96,500, and lastly divided by 2. So we're going to have 0.3175 gram. So this is the mass. This is the mass of copper that will be deposited when the same quantity, look at the same quantity of current, when this same quantity of current is passed through the silver nitrate solution and also the copper sulfate solution. So these are the kind of questions you can see in your exams. Okay, very simple, and I believe you understand this. For more information, go to the app and look at more examples we have used there to illustrate this same topic we have been talking about. So today, let's look at the factors affecting electrolysis. Okay, now the factors affecting electrolysis, the first one is the positions of the ions in the electrochemical series. Okay, now these ions we are talking about both the cations and the anions. Okay, the cations include all those metals, right? Potassium, sodium, calcium, magnesium, aluminium, down. So the electrochemical series will tell you the one that will preferentially discharge over the other. It has been found that as you go down the electrochemical series, for the metals or the cations, as you keep going down, the ions that are down will preferentially discharge over the one at the top. Okay, so if you have electrochemical series and you have, as you keep going down from potassium down to, let's say, hydrogen will discharge over the potassium because it is down the series. So as you go down that series, their reactivity decreases, okay, and their reducing agent ability also decreases in terms for the metal. So the electrochemical series will tell us the one that will discharge over. So if I have a solution, if I have electrolyte, if I have a solution that has both copper ion and, let's say, zinc ion, the one that will discharge between these two depends on the electrochemical series. Okay, copper will discharge over zinc because it is what? It is down the series. Okay, while zinc is a way up a little bit, so the distance is very far. So in terms of electrochemical series, the position of the ion matters to determine which one will be what? Preferentially discharged. Now the next one is the concentration of the ion. Now this concentration of the ion will also determine which one will be electrolyzed. Okay, the higher the concentration, the more likely the ion to be what? Discharged or electrolyzed. Okay, so the concentration of the ion affects the electrolysis. If the concentration is too low, then that one that is low will likely not to what? Discharge. The one that will discharge is the one that has a high concentration. So concentration plays a crucial role in electrolysis. Now the next one is the nature of electrode. Now electrodes can either be inert or they are active. Okay, so some electrolysis requires you to use an active electrode, while some requires you to use an inert. Inert means they are not going to be that active, okay, they will just be silent throughout the electrolysis, because they might be, if they are active, they might affect the electrolysis. So electrolysis, some electrolysis requires an inert electrode, while some does not require this inert. Some requires active. So during the course of electrolysis, or looking at examples of electrolysis, you should be able to know the type of electrode that is suitable for that particular electrolysis to work, to thrive. So the last one is the nature of the electrode. Now some electrolysis can take place in aqueous solution, while some can take place in what? In a molten state, okay? While some can take place in a molten state. So molten state means like it's not in aqueous form. It's just like a kind of a little bit dry, sort of. So aqueous solution, some electrolytes are in aqueous solution, while some are in molten state. So the electrolyte, you have to be able to know, for example, electrolysis of brine, okay? Some electrolysis of brine is either in molten state or in what? Aqueous state. So these two different states will give you two products, to give you two different answers, depending on the one you are working with. So these are the factors, the main factors you consider when you are looking at electrolysis, to be able to understand what is happening in that particular electrolysis you're trying to do.